The one thing that probably causes some of the most pain in chemistry and in organic chemistry in particular is just the notation and the nomenclature, the naming that we use. What I want to do here in this video is to just make sure we have a firm grounding in the notation and in the nomenclature or how we name things. And then everything else will hopefully not be too difficult. So just to start off, if I just have a chain of carbons, and since the organic chemistry is dealing with chains of carbons, let me just draw a one carbon chain. It's really kind of ridiculous to call it a chain. But if we have one carbon over here and it has 4 valence electrons, it wants to get to 8. That's the magic number we learned in just regular chemistry for all molecules. That's the stable valence structure, I guess you could say. So it is a good partner to bond with is hydrogen. So it has 4 valence electrons. I am talking about the carbon here. The carbon has 4 valence electrons, and then hydrogen has 1 valence electron. So they can each share an electron with each other. And then they both look pretty happy. I said 8 is the magic number for everybody except for hydrogen and helium. Both of them are happy because they are only trying to fill their 1s orbitals. So the magic number for those two guys is 2. So all of the hydrogens now feel like they have 2 electrons. The carbon feels like it has 8. Now there's several ways to write this. You could write it just like this and you can see the electrons explicitly, or you can draw little lines here. So I could also write this exact molecule, which is methane, and we will talk a little bit more about why it's called methane later in this video. I can write this exact structure like this, a carbon bonded to 4 hydrogens. And the way that I've written these bonds right here, you could imagine that each of these bonds consists of 2 electrons, one from the carbon and one from the hydrogen. Now, let's explore slightly larger chains. So let's say I have a 2 carbon chain. Let me do a 3 carbon chain here. So if I were to draw everything explicitly, it might look like this. So I have a carbon. It has 1, 2, 3, and 4 electrons. 1, 2, 3, and 4. Yeah. Maybe I have another carbon here that has, let me do the carbons in slightly different shades of yellow. I have another carbon here that has 1, 2, 3, 4 electrons. And then let me do the other carbon in that first yellow. Then I have another carbon. So we have a 3 carbon chain that has 1, 2, 3, 4 valence electrons. These are unpaired, and if not specified, it's normally going to be hydrogen. So let me draw some hydrogens over here. So you're going to have a hydrogen atom placed here, another one positioned over there, one located on this side, and yet another right across. Essentially, hydrogen atoms are arranged all around, occupying various spots in the structure. Now notice, in the molecular structure I've drawn, there are 3 carbons, each forming 4 bonds. This one has bonds with 3 hydrogens and another carbon. This guy has a bond with 2 hydrogens and 2 carbons. This guy has a bond with 3 hydrogens and then this carbon. And so this is a completely valid molecular structure, but it was kind of a pain to draw all of these valence electrons here. So what we are going to see later in this video, there are even simpler ways to write it. So if we want to at least do it with these lines, we can draw it like this. So you have a carbon, 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 and then they are bonded to the hydrogens. So you'll almost never see it written like this, because this is just kind of crazy. Hydrogen, hydrogen, at least crazy to write. It takes forever. And it might not be clear where these electrons belong. So they have 2 electrons there. They're shared with these 2 guys. But if we were to draw it with the lines, it looks just like that. So it's faster to draw. Same exact idea here and here. And in general, and we will go in more detail on it, this 3 carbon chain where everything is a single bond is propane. Let me write these words down because it's helpful to get. This right here is methane. And as we go along, you will start to see the rhyme and reason behind this naming convention soon enough. Now, this is methane. And over here, we have propane. Interestingly, there's an even simpler way to represent propane, which we will look at shortly. You could write it like this. Rather than explicitly drawing out these bonds, you could represent this section in a different way. You might write that this part right here corresponds to CH3. So essentially, you have a CH3 group linked to a CH2 group which is then further connected to another CH3 group, forming the overall molecular structure. The important thing is, no matter the notation, as long as you can figure out the exact molecular structure, that last CH3, whether it's this, or that, once you know the structure, you can draw any from the others. Now there's an even simpler way to write this out. You could write it just like this. Let me go ahead and do it in a different color. You literally could write it. So we have 3 carbons. So 1, 2, 3. Now this seems simple. And you're like, how can this thing right here give you the same information as all of these more complicated ways to draw it? Well, in organic chemistry, any of these, I think they call it a line diagram or a line angle diagram. It's the simplest way, and it's actually probably the most useful way to show chains of carbons or to show organic molecules once they start to get really, really complicated, because then it's a pain to draw all of the H. But when you see something like this, you assume that the endpoints of any lines have a carbon on it. So if you see something like that, you assume that there's a carbon at every endpoint. And then you know that carbon makes 4 bonds. There are no kind of charges here. All of the carbons are going to make 4 bonds. And this carbon has 2 bonds, so the other 2 bonds are implicitly going to be with hydrogens. If they don't draw them, you assume that they're going to be with hydrogens. This guy has 1 bond, so the other 3 must be with hydrogen. This guy has 1 bond, so the other 3 must be hydrogens. So just drawing that little line angle thing right there, I actually did convey the exact same information as this depiction, or this depiction. This really simplifies things. And sometimes you see things that are in between. You might see someone draw it like this, where they'll write CH3 and then they'll draw it like that. So that's kind of combining this way of writing the molecule, where you write the CH3s for the endpoints, but then you implicitly have the CH2 on the inside. You assume that this endpoint right here is a C, and it's bonded to 2 hydrogens. So these are all completely valid ways of drawing the molecular structures of these carbon chains or of these organic compounds.